Well, it's 6 p.m. Eastern Standard Time, and this is the Randomizer. I'm Charles Schultz, and I will be taking you on a walk through a new technical term today. And today's special term is, of all things, digital paper, electronic paper. Electronic paper is one of those new things we see, and it's popping up all over and all sorts of things. We're going to talk about what it is, how it works, and the interesting parts that come together to make it function. First of all, I want to go over our need to share a few interesting things with you. Number one, we have our Meta World Lesson 2 happening tonight at 9 p.m. Eastern Standard Time. If you'd like to join us for that class, go to the schultzlaboratories.com website or universesciencecenter.com website. Click on the buttons and get into our class. 9 p.m. tonight, Eastern Standard Time, Meta World 2. We're going to be looking at pragmatic tools and mental development. It's going to be a fascinating lesson. It's a 6-part series, and you haven't missed much. The previous lesson is online. That'll be available to anybody who wants to see it. And next, please join Schultz Laboratories or Universe Science Center and become a supporting member. We're adding more galleries, more content, and more information. It's a fully virtual 3D world. You can walk around in, bring your kids in there, put the Oculus on them, let them walk around and play and interact with some of the things. And it's fascinating. You can visit the planets and float around them just as if you're in a spacecraft. In some cases, you can actually go down and walk on the surface. So those things are going to be expanding greatly in the near future. So, electronic paper. Well, this story has 4 interesting components to it. Chameleons, lizards that change color. Silicone, used as a skin or a template to hold materials. Electrical components called capacitors, and an interesting thing made out of carnauba wax called the electret. So let's take each in turn. How does a lizard actually change color? How does a chameleon change color? And we see it happen, and it's just kind of an amazing, magical looking process. You know, if you could figure out how to do that with a material other than the skin of a lizard, you probably could think of 1,000 applications for something like that right away. Interesting materials have been developed that change color to camouflage, military vehicles. There are color changing or thermochromic paints that you can put on coffee cups or even on vehicles. But this is a little bit different. When a lizard changes color, what's exactly happening in its skin? Well, you can imagine a board covered with holes. And each hole has a colored tissue in it that's been pulled in through the center so you can't see it. But the 4 corners are on rubber bands. And if you let it go, the rubber bands will pull the tissue out and the color will show. And so you have a string you can pull and the tissue goes back in the hole and the board is white. You let the tissue come out, and it turns green. That's kind of a principle that you can imagine pretty easily. Lizards have cells in their skin that have bundles of pigmentation similar to a tissue that can come out and be shown or be wadded up and hide and change the color. Pretty simple. Now, how do we turn that into a device that we can actually produce and use? Well, first, you make a bunch of little dots of, let's say, black plastic that are microscopic in size and little dots that are white plastic that are microscopic in size. And you charge each of those little dots electrically. So some of them are positive, like all the black dots might be positive, and some are negative. Some all the little white dots might be negatively charged. The question is, how do you keep the charge in the dots? Well, there's a material called carnauba wax or carnauba, depending on what part of the country you're from. And this wax is similar to beeswax, but it has one very interesting property. It can accept a charge of high voltage and it can store it. Now, anybody who works in electricity or electronics knows what a capacitor is. A capacitor is a device that has 2 metal plates or conductive plates, and there's an insulator between the plates. And when you put a charge on the plates, the metal plates each hold that charge by moving the electrons in or out of the insulator. So if I put a negative charge on the plate on the left, for instance, what will happen is all the negative charges in the plastic will flee from it and leave positive charges on the surface next to the negatively charged plate. And then the other plate has a positive charge. Well, it draws the electrons out of the surface and leaves a positive charge there. So when you charge each plate, the negative and the positive charges move out of the plastic and situate themselves on the surface. It's static electricity, just like running across a rug in the winter when it's really cold and building up a charge and touching the doorknob and feeling that snap of electricity. You've picked up charged particles from the rug and now they've been grounded by the doorknob. So what happens if the charge doesn't get grounded away? Well, a capacitor can be charged or discharged many times. But some materials, like that carnauba wax, can form a device that isn't a magnet, but an electret. And it's a device that stores the voltage in the wax and insulated that will not release it. So once the wax is charged up, or a similar material like that is charged up, and coated in an insulating material like plastic, the charge can be sensed through the plastic, but it cannot be removed. So these electrets remain positively or negatively charged. Now, many, many years ago, when people used phonographs, they may remember that a cartridge came out for the tone arm on this is for playing a vinyl record. The tone arm had a little sensor that read the vibrations, and in it was an electret in many cases, which was used to measure the various little vibrations of the needle and convert that into music. Microphones often have electrets in them today. It has a little film, metal film above the electret, and as that diaphragm moves, the difference in charge is picked up and amplified, and that's how the microphone actually turns your voice into sound, an electrical signal. The sound of your voice, into an electrical signal, and that's amplified. So now we have all these little particles that have electrets in them, charged up, and some of the dots are one color and they're positively charged, another set of dots is another color and they're negatively charged. And all these little dots are placed in tiny little bubbles full of a liquid. And those little bubbles full of liquid have the dots mixed up in them. Now the cool thing is, if I place a charge on one face, like a negative charge, all of the, like the black dots will go toward that charge, and all the white dots will flee from it. Well then, just by placing a charge on either side of that pixel or dot, I can change it from white to black. Now, the white ones are the same color as the background, and that means you've erased the line. And the black ones are just like having a pencil stroke being made, and that is where your graphite or your line will show up. Now imagine millions upon millions of these tiny dots embedded in a flexible skin of silicone rubber. And they're in there in the same pattern as perhaps a beehive, like hexagons. If you pour a bunch of little BBs on a flat plate and shake the thing, all the BBs will fall together into almost perfect hexagons. Well, this is what these little dots do. They fall into a pattern in the sheet, and there they set when the silicone hardens. So now you have this page that is made of silicone rubber or a similar flexible material, and embedded in the surface of it are millions upon millions of tiny pixels, these dots containing white and black plastic particles that are electrically charged. On the back of the sheet, there will be a whole bunch of, let's say, parallel horizontal lines, and each of them is a wire. And on the front will be a whole bunch of parallel vertical lines, and each of those is a wire. And it's just like a piece of screen wire, except these are insulated wires. And where the grids cross, at every point where it crosses, there's a pixel, there's a dot. And when you select the vertical line, and then you select each horizontal line in turn, you write all the dots to black or white in that column. And then you go to the next wire and energize it, and put a charge in there to write all the white and black dots for the next column. And when all the thousands of columns have been written, you have your image on your paper. Then they combine that with a sensor that can tell where your stylus is located on the sheet. And so as you take your stylus and you move it across the page, just like your finger on the surface of a cell phone, it determines the position and it turns the dots over and draws a line. So there's a computer chip managing all of the charges on all these little capacitive dots. and writing the image on it. So by stealing a little technology from the chameleon and a little bit of wax and some high voltage capacitors and embedding it into skin of silicone, they make artificial paper that is electronic in nature. And any image can be written on it and it will stay there until you alleviate the charges, until you remove them. So it's really a very complicated material, but in the end, it simply does what any sheet of paper with a pencil would do. It draws an image. And it can be snapshotted and stored as a digital image. Software in any clipboard with this can literally do image recognition and convert the drawn letters into text that can be gone and put into an editable document like a PDF or a Microsoft Word document or anything. So using character recognition, whatever you draw on the paper can be snapshotted, turned into an actual document, and stored digitally. Or you can just store the picture. So this is what electronic paper is. It's a composite of many different technologies, started with the idea of a lizard changing color and high voltages, and ends up being a really interesting and intuitive artistic drawing and writing device, such as a digital clipboard. So that's what we're really focused on today. Taking a technology like this means you can create signs, billboards, anything, and rewrite them. And the beauty of it is they now have it in many different colors, not just black and white like a pencil on paper, but it also stores the image at zero power when it's turned off. Now keep in mind, this does not emit light. It's just as passive as a sheet of paper in that result, in that manner. You have to shine a light on it in order to read it. But once the image is written on there, it doesn't just decay when you turn it off. It retains the image. So fascinating stuff. And I'm looking forward to seeing many different forms of this technology for a lot of other purposes as well. Now, if anybody has any questions, the floor is open and I'd be happy to take them. Meanwhile, please go to schultzlaboratories.com or universesciencecenter.com and subscribe, become a member, join our classes and take the lessons. Support our growth and make it available to your family and your friends. Let them see what it is. People get very excited about this. Homeschoolers love it. If you're out of school and you need to be able to go somewhere and study and practice, this is a great way to do it. We're converting electronic theory into challenges and games so you can learn about capacitors, resistors, inductors, microchips and how they're fabricated, how logic gates operate. And I'm soon going to be starting a whole section on robotics so you can go in and learn how to set up your soldering bench, how to put a relay driver together, and how to build and program robotics. It's going to be a lot of fun there, and I know people love that sort of thing. Anything that teaches you how to get hands-on, get your hands dirty and learn a real lesson and do something is always a lot of fun. It's very, well, it's worthwhile. We improve ourselves by learning. So if there are no questions and no suggestions, and I don't see anybody's posted anything here, well, I guess I'm going to wait just a moment here and also point out that in times past, we had LED light systems you could put on a billboard or on the surface of a vehicle or an aircraft and use them to camouflage it. During World War II, bombers who were moving in to start shooting at targets would fly out of the sun and they would put lights on the leading edge of their wings and brightly illuminate themselves so they blended into the sky. And it was just a form of camouflage. Today we have fabric that can be draped over an army tank or a vehicle and electrically will change color. And it's an electrochromic display that's embedded in plastic. Different voltages make different colors, so they can pattern after camouflage, leaves, sticks, whatever. It becomes the camouflage outfit for a vehicle. Lately, they have used infrared LEDs, and they've come up with a method of camouflaging vehicles such as tanks or troop carriers to look like a Volvo by matching the infrared signature. So very clever stuff is happening there. I'd like to see a lot of that, engaged in our day-to-day lives in positive manners. So, well, I haven't had any questions as of yet, and so I'm going to wrap this up with a fascinating little thing that I saw, and I love this. This is from Luke 6:37. Do not judge, and you will not be judged. Do not condemn, and you will not be condemned. Forgive, and you will be forgiven. As a commentary on that, we're all often driven to look at somebody and go, nah, that guy's an idiot. The fact is, all of us in our own way are idiots. We all have flaws, and we all do foolish things at some time. We have to learn to recognize and learn from it, improve ourselves, try to knock off the rough corners and become a little more civil. We are Stone Age people with handfuls of modern technology and often don't have the innate ethics to use it properly. So, in closing, just be nice to people. And my favorite, make the world a better place. So thank you for watching today. I really appreciate it. And I hope that you all have a great life. And tune in tomorrow for our next randomizer. Thank you.